Welcome back for part 2 of section 5.5. We're doing substitution still. Here we got an even trickier problem. Looks like I got trig times trig, but trig squared times trig. All right, I love it. So I'm recognizing this is two things being multiplied together. First thing I'd like to do, though, is I'd like to rewrite this so it's a more clear representation. This is the integral of the quantity, the sine of 3x, that quantity is squared, multiplied by the cosine of 3x dx. Now, what some people are tempted to do is they're tempted to look at this and say, oh, there's composition, and they want to say that u is equal to 3x. And they ignore the fact that that isn't how this is going to work, because if they attempt to go down this road, they get du is 3 dx, and then they try to make a substitution, and they do. They get a substitution to work, they end up with this. And that still has too much junk in it. It doesn't work, okay? So you want to be careful, and you always want to start from the outside and work in. Here, this entire term is the largest composite that I'm seeing here. So I'm going to say that u is equal to that large composite term. U is the sine of 3x, and then the differential du is going to be the cosine of 3x times 3 times dx. Now, if you're wondering, hey, where did that 3 come from? Chain rule. Don't forget the chain rule when you're taking your derivative. Okay? Now, I'm going to see if my pieces and parts match. This matches this, but this does not match that because I've got an extra 3 here that isn't up there. So again, like the other times, I'm going to fix that, and I'm just going to rewrite this blue line as 1/3 du is equal to the cosine of 3x dx. And now this matches, and I can perform my substitution. So then I will do the substitution, and I get the integral of u squared times 1/3 du. I'll ask myself, did the two things that are supposed to happen? That is, did all the x's turn into u's? And is what I ended up with easy to integrate? Well, that 1/3 will just move out in front, and I'll get 1/3 times the integral of u squared du, which I can integrate, and that's going to give me 1/3 times another 1/3 u cubed plus c. This isn't quite done yet, though. I need to clean that up a little bit. 1/3 times 1/3 is 1/9, and I need to do a back substitution on u. U was the sine of 3x cubed, again, plus c. Substitution. So much fun. I love these problems. They're great. More, you say? I have more. How about this one? The sine of x divided by the cosine cubed. Okay? Now, for substitution to work, it's supposed to be two things multiplied together, and this is two things divided, but that's easy enough to fix. I'm just going to rewrite this as the sine of x times the cosine of x cubed dx. Okay? So here we go. I'm seeing composition, so I will get u be the inside of the composition, and then the differential du is going to be the derivative cosine. Derivative cosine is negative sine of x dx. I'm seeing the dx, I'm seeing the sine, I'm not seeing the negative, so I'll just modify that down here and call this negative 1 times du is equal to plain old sine x dx. Now everything matches, so I can perform the substitution. I'm going to have to go on to this next page here to make this work, so I'll have to change my font size a little bit there. And I get the integral of u cubed times negative 1 du. I'll pull that negative 1 out in front. Negative integral u cubed du. Both things that were supposed to happen. U's turn into, or x's turned into u's. Simple integral pops out. I perform the integration. Negative 1/4 u to the 4th plus some constant c. Back substitute negative 1/4 cosine x raised to the 4th plus c. Yeah, u is cosine. I almost forgot. I had to go back and check. Love this stuff. Right? More? I've got more. Here's an interesting one. The integral of a tangent. Right? Well, if I attempt to, but wait a second, nothing seems to be right here. This isn't composition in any shape or form. This isn't tangent of x squared or tangent of 3x or anything like that. There's no square roots, there's no powers. But there's nothing I know how to do to take the antiderivative tangent. So what I'm going to do is I'm going to do what I always do with trig and rewrite. This is the integral of sine x divided by cosine x dx. Okay. That's the same as the integral of the sine x times cosine x to the -1 dx. And now this, two things multiplied together, one of them is composition, substitution. U is the inside piece from the composite part. The differential du would then be negative sine x dx. I've got the sine x and I've got the dx. I don't have the negative, so I'll fix that. So -1 times du is going to be equal to sine x dx. Right? So then putting everything in and performing the substitution, I'm going to get then the integral of u to the -1 times -1 du. If I take that -1 and I move it out in front, I've got -1 integral u to the -1 du. I know this one. This is a fundamental integral. The integral of u to the -1 is the natural log. So -1 times the natural log of the absolute value of u plus c. That's still not right though, because I need to, what does that need to do? Oh, I need to back substitute. So that's going to give me -1 times the natural log of the absolute value of cosine x plus c. And then if I wanted to, I could use one of those logarithm rules and turn this into an exponent, or I can just leave it like it is. I prefer just leave it like it is and call it negative natural log absolute value cosine x plus c. Man, this stuff is fun. Right? More, you say? Okay. This is a hard one. This is what we refer to, sometimes we call this a double substitution or a more complicated substitution. I hesitate to use the word double with it because then people think you're making two different substitutions. But what you're really doing is using one substitution in two different ways. All right, so let's work through it and see where the problem shows up and see how to fix it. Two things multiplied together, one of them is composition, call that one u. U is 2x plus 1. Differential du then is the derivative of that 2 dx. I perform the substitutions. I get the integral of x times the square root of u times 1/2 du. Okay, I left that a step here. This line, we would turn this into 1/2 du is equal to dx. Okay? So the dx here turned into 1/2 du. The 2x minus 1 turned into that. But what's the problem here? That x never went away. And because that x never went away, this is what we call this, or I refer to these as a double substitution. We're going to have to do another substitution to make that x go away. All right, so stay with me here. If u is equal to 2x minus 1, does that mean that u minus 1 is equal to 2x? Or that u minus 1 divided by 2 is equal to x? And now I'm going to take this and perform a second substitution right there. And so my pink integral is going to turn into u minus 1 over 2 times the square root of u times 1/2 du. Now I know there's at least one person watching this who's going to say, that doesn't look any better than what we started with. Well, give me a moment to do a little bit of algebra on it, and trust me to look better. This 2 and this 2 is going to turn into a 1/4 that I'm going to pull out in front. I've got u minus 1 then, times u to the 1/2 du. That turns into 1/4 times the integral of u to the 3/2 minus u to the 1/2 du. And now at this point, this is, at this point, this is an integral that we can actually do. And now it's better. I can't do this one up here because I don't know how to multiply an x times a root. That doesn't work for me. But down here, I know how to multiply a plain old root times a u. All right, so I'm going to get 1/4 times integral of u to the 3/2 is going to be 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c. Distribute and back substitute. I'm going to get 1/10 times, what was u again? Oh yeah, 2x plus 1 to the 5/2 minus 1/6 times 2x plus 1 to the 3/2 plus c. And of course, if you don't believe that this is true, just simply go ahead and take the derivative of this line right here, and that will give you your original integrand up there. Just go ahead and do that substitution real quickly, and it'll work out just fine. All right. Substitution. Solving integration problems. These are indefinite integrals using substitution. We got time for one more, and then we'll move on to definite integrals. Right? So our last one right here. Right? This looks odd. The reason I say it looks odd because this power is bigger than this power. I shouldn't have fifths out there and seconds under the root. I'm thinking that this is going to make me do kind of what I did in the last one, some sort of second substitution or a double substitution. But I'm just going to start working the problem and see what happens. There's my composition. So I will say that u is equal to 1 plus x squared. The differential du then is going to be 2x dx. Okay? Which if I clean up that coefficient is going to give me 1/2 du is x dx. If I perform my substitutions, then the integral becomes the integral of the square root of u times x to the 4th times 1/2 du. Now, I know that at least one person is squealing right now because they're so excited, but for the rest of us, right? What on earth is an x to the 4th doing there? How did that show up? Well, my substitution was x dx can get replaced with 1/2 du. So this piece right here, I'm thinking of this as x to the 4th times x dx. So then I can take that and do that, and this just kind of tags along. It's in fact, it's sitting right there. Right? Okay, so I'm at the green, and I'm unhappy. The reason I'm unhappy is because sitting at that green, I have u's and x's in my integrand. So I need to figure something out. I need to figure out a way to make this thing work. So I think I can do another substitution. So let me see if I can figure this out. If u is equal to 1 plus x squared, then u squared would be equal to, wait, no, that's not going to work. Oh, u minus 1 would be equal to x squared, and u minus 1 squared would be equal to x to the 4th. Maybe that'll work. Okay, I'll try that. So now I've got this. I've got the square root of u times u minus 1 squared times 1/2 du. Well, I got rid of my problem that had x's and u's mixed up, but now I've got a mess. I'm hoping algebra will help me out here. I'm going to pull that out in front, and I'm going to distribute this one out. Right? Now, if you're asking why I'm going to distribute this one out, the only way that this integrand is going to integrate is if I can actually do this multiplication, that root u times something. And I can't multiply that root u times something as long as that squared is sitting there. Right? So I'm going to multiply it out. Then I'm going to distribute the u squared. And then I'm going to go, okay, I can make this happen now. All the x's turned into u's. Everything is integratable. I'm going to integrate. U to the 5/2 is going to be 2/7. U to the 7/2 minus 2 times 2/5. U to the 5/2 plus 2/3. U to the 3/2 plus c. Distribute that 1/2 into there, and I get 1/7. And what was u again? Oh yeah, u is 1 plus x squared times 1 plus x squared to the 7/2 minus, let's see, what's that going to be? Minus 2/5 times 1 plus x squared to the 5/2 plus 1/3 times 1 plus x squared to the 3/2 plus c. And again, like every other time, if you are uncomfortable with this being correct, just take a moment, take the derivative of that, and see if you get the original integrand after about 5 months worth of simplification. Sound good? Okay, that brings us to the end of part 2. We'll come back and take a look at definite integrals in part 3.